Okay, so this lesson we're just going to bring our information that we just learned about degree, leading coefficient together and end behavior, and to just summarize it here. So one thing we know is if we have a leading coefficient that's positive, that would be like the regular ones that we looked at, like x to the fifth, x squared, there's just a positive 1 in front. If positive acts normally. So for example, an odd degree polynomial would be a cubic or a fifth power, and the end behaviors would go up on this side and down on that side, because that's what a cubic or a fifth degree function would look like with a positive leading coefficient. That's the normal. Even, well, when I'm thinking even, I think my friend the quadratic, both are going to go up on both ends. So as x approaches infinity, x approaching negative infinity, y is approaching infinity. Now when I change the leading coefficient to a negative, what that does is it causes a reflection in the x-axis. You've probably seen that before when you did transformations. And that is going to change the end behavior to exactly the opposite, meaning instead of going up on the right, it's going to go down and up on the left. And we know with a quadratic, when you put a negative in front, what happens instead of a smiley face? Oh yeah, you get the frown. So they both head downward at the ends. So these are our just little sketch to help us remember about the end behaviors if you have an odd degree, even degree, or a positive or a negative leading coefficient. So let's do this example. I'm just going to move this up a little bit. That's good. Okay. For the following function, f of x equals x to the fourth minus 1, state the degree and the leading coefficient, the end behaviors, the x-intercepts, and use this information to sketch a possible graph. So this is just a little sketch, but there's things we know about the polynomial from just what we've learned. For example, what is the degree? Well, the degree is the highest power of x in our polynomial, in this case 4, so it's an even degree. Our leading coefficient is a positive 1, so it is it's an positive leading coefficient. So my end behavior then, if it is a leading coefficient that's positive, that's going to be behaving normally, no reflection, and a degree that's even means like the quadratic, it's going to both go up. So how do we describe that? We say as x approaches infinity, f of x is also approaching infinity. And as x approaches negative infinity, f of x will be still approaching infinity. Both will go up. Okay, so we have in behavior. The last thing they asked us to find was the x-intercepts. Now, x-intercepts, like we've been learning since grade 9, is when the y is equal to 0. So when we have our function f of x, which is just like y, is equal to 0, solve for x. All right, well, this is one of those ones where, I mean, I could try to factor in all of that business. This is definitely one where I could isolate the x. So even though it's x to the fourth, there's only the 1. So I can move the 1 over, take the fourth root of both sides. Remembering, of course, when you take an even root of both sides, you have to include both the plus and the minus as answers. So I have two x-intercepts, one at plus 1, one at minus 1. And there's my end behavior. Now, I'm going to move it up just a little bit more. And I'm going to try to make a possible sketch. And it's just a sketch. I am going to put my x and my y and my x-intercepts cross the x-axis at 1 and negative 1. The end behaviors are they're both going up. So that means here it's going up, here it's going up. And, oh yeah, they somehow have to meet. So clearly it's going to be something like this. And we could have figured this out a little bit because we can kind of see that that's a translation down 1 of the x. So that would be a good approximation of a sketch for that function.